Hello everyone, I'm Krista-Lozada and I'm here to share our journey, learnings, challenges, experience, basically everything within the realm of our move to the cloud and adopting automation. Little bit about me, I'm a senior IT specialist at Asian Development Bank. I have the great privilege of leading the middleware, integration, mobility, and desktop engineering teams. Before I start, I want to do a big shout out to Bay again. Thank you so much for sharing your awesomeness and talent with us by doing all of the illustrations in this presentation. Who are we? We're the Asian Development Bank, and our mission is to eradicate poverty within Asian Pacific. We are not like commercial banks. We are a development bank, and basically we give grants, loans, technical assistance to developing countries to help them tackle complex problems such as water, transport, climate change, and even gender equality. Our headquarters is at Manila, Philippines, and we basically have around 40 offices within the region. Like all organizations, back in 2018, we planned for digital transformation. For us, it meant embracing the cloud, but unlike other organizations, it was not a cost savings exercise for us. Rather, was it a move for elasticity? We were driven by resiliency. You see, Manila itself, is expecting a big earthquake anytime soon. And we need to ensure that the organization is resilient when this disaster strikes. That meant moving to the cloud. Unfortunately, it's not always straightforward moving into the cloud, right? There's a lot of complexities in there, especially for a bank. Our team had to make sure that we had set the right foundations in place. We had to make sure that our move to the cloud is going to be as seamless as possible. Traditionally, our decision is to make sure, or our approach is to make sure that we find one tool to rule them all. But for this project, and one of the foundations that you have to put in place is to have infrastructure as code, right? Modern practices, modern technologies to enable you to move fast at the cloud. After doing our research, it made sense for us. Instead of one tool to rule them all, what we needed was one tool that does one thing very well and have them play nicely. So for us, it was very clear. For DayZero Infrastructure, it's going to be a Terraform job. Terraform does a very good job of managing immutable infrastructure. Day 1 to day N infrastructure, whenever your infrastructure needs to change, it's going to be an Ansible job. We were so excited. We were supposed to start this project by April 2020. March 2020, boom, got hit by COVID. And I guess like everybody else, we were all blindsided. That meant, for us, literally overnight, ADB headquarters had to close 1 month before our project was supposed to start. So we had our doubts. We were thinking, are we supposed to continue this? Because we haven't really done projects 100% remotely. At the same time, the ADB never closed its doors to its clients. In fact, it tripled its COVID response initiatives from $6.5 billion. It actually increased it to $20 billion to do COVID efforts. And so, unfortunately, it also meant there's some urgency to move fast. We were driven to innovate. But at the same time, we cannot haphazardly throw security or resiliency out the window. We had to make sure that we move fast, but at the same time, always secure and architecturally correct. And then that meant we had to continue the automation project, even if it meant doing 100% remote for a project that we have no experience of and a technology that we are not super aware of. We didn't want to re-engineer every single thing. What we wanted was to leverage on others' experience. There's a lot of companies, a lot of partners that have already done this. They live, breathe DevOps and automation. And we wanted to learn from them and make sure that we can make this project as successful as possible. Fortunately, we were able to finish within 45 days. And by finish, I mean we had a platform working, fully working, and we're able to integrate spin up servers into the cloud in Azure and VMware on-premise. Of course, like any other platform, even how powerful or how amazing it is, platform by itself never solves problems. People do, right? So what we had to do was, if we wanted to scale our automation capabilities, we need to make sure the foundation is ingrained on our people, instead of just trusting the tool to do itself. Any tool can be abused or can be used wrongly, will not solve anything. So we had to make sure that we had the proper tenets in place and live by our principles whenever we have to do any project or any initiative within automation. Rule number 1, you do everything in code. And what do I mean by that? So let's start from the very beginning. We only had Azure DevOps and Terraform open source in the beginning, I guess. And then we, using Terraform open source, provision Terraform Enterprise. I kind of love it because it's such an inception thing to do. You use Terraform to spin up Terraform. Once Terraform Enterprise was spun up, we've actually used it to create our Ansible platform. Now, this was the platform that we finished within 45 days. Some of you might find it impressive, some may not. But there's a little bit of complications in there as well, such as the virtual machine scale set wherein Terraform is spinned up to, or even the virtual machines that Ansible is referencing to, has to use ADB golden images. It has to be CIS hardened. It has to have the agents in place, basically blessed by security and said that, this is production grade. So that meant that Azure DevOps have to spin up another pipeline, which uses Packer, to create the image that is referenced by the Terraform scale set. At the same time, these workloads have to reside somewhere, right? And we were ballsy, I guess, enough to be the first workloads to run in our data center in the cloud. So imagine this. We were building Terraform Enterprise, at the same time, another pipeline building the images that's going to be used by Terraform Enterprise, and at the same time, have another pipeline that actually spins up the data center where Terraform Enterprise is going to live on. Every single change on the image or the data center would mean that we would have to respin our infrastructure as code platforms in there. If we have done this manually, probably we were faster the first iteration, because we didn't have to write code in there, but it didn't give us the flexibility to change on demand. By writing it as code, every single change, we have the latest source of truth, I guess, or the latest configuration in place as a blueprint in our code. And it allowed us to move because any change on the data center, we would just destroy our existing platform, reflect whatever is changed on the code, and then spin it back up new. We love putting everything as code so much that, like a boss, we've actually forced, or not really forced, maybe encouraged our management team to adopt a policy wherein no user has write access to our cloud infrastructure. So as you can see, our contributor and owners are actually either service principal of Azure DevOps or the managed service identity of the scale set in Terraform itself. Any user would only have reader access, meaning that if you need to change any infrastructure, you go change it at the code level. Of course, we have break glass accounts that would allow us to do the necessary changes as a person, but that's really more of a scenario wherein if the systems fails or there's something really, really wrong that has gone wrong. The road that has to be traveled has to be update anything over code. The second rule is you shouldn't repeat yourself. There should be one piece of code that defines a piece of infrastructure and one piece of code that defines the business logic in ADB. In here, for us, it meant breaking down monolith. And monolith is not just on traditional applications. Even infrastructure as code can have monolith. And now I'm going to tell you a lengthy story of how using workspaces and modules saved us on an architecture dilemma. So let's start with the data center in Azure. And basically, you have your hub virtual network. Traditionally, our hub has routing and security components in it. We're adopting a hub and spoke model in our cloud data center. And basically, in these spokes, we've decided to divide the subnets by data classification. So workloads within the same data classification, so for example, sensitive application, they can talk to each other. But if workloads need to talk to another subnet using a user-defined route table, we actually force them to go through the firewall. So in there, it allows us to monitor all ingress and egress of all traffic outside of the subnet. That also meant that each subnet would have its own UDR attached to it, which is managed by Terraform, thank God. In the hub virtual network, we also have other subnets in there. So for example, our infrastructure as code platforms, Terraform and Ansible, are stored in the hub. Security mandated us that there should be no public endpoints for a PaaS resource in Azure. So that means if you need your PostgreSQL, your Redis cache, your storage account, every single thing should have a private endpoint in there, and no public endpoint should be there. So makes sense, I guess. Unfortunately, what we had to learn the hard way was that Azure, when you create a private endpoint, automatically creates a system route from the subnet where the private endpoint is to everything it's peered to. So what does it mean exactly? Well, that means a non-prod server has direct line of sight to any private endpoint, even if it's a production-sensitive database. So of course, that's a big loophole for us, right? It totally bypasses our architecture wherein all ingress and egress is enforced, or at least goes through the firewall where we can do inspection and enforce certain rules. So the solution for this problem is actually pretty simple. We would remove the subnet from the hub virtual network and then create our own private endpoint virtual network in there, have them peered to the hub. Of course, we need to add the private endpoint virtual network CIDR in the route table, and that would force the traffic back to the firewall. There's still a little bit of an issue in there because we still have the infrastructure workloads in the hub, which has now direct line of sight to all private endpoints because it's still peered in there. So we need to remove that and then place it in its own virtual network. And suddenly, this would have solved all of our problems because of that system route that's created on the private endpoint. It would have solved it, but at the cost of complexity, because now our issue is that we added 2 different virtual networks in our data center in order to accommodate this use case. Thankfully, Microsoft, by September 2, 2021, created a public preview that allows us to create a wider subnet range for route tables. So that means that we can yank out the virtual networks for PEs and infrastructure, return them back to the hub, and then we would just need to add the private endpoint subnet CIDR in the route table, and that would still force it in the firewall. Unfortunately, the public preview is only for the US. So there's no love for us here in Asia Pacific. That means that for the meantime, while we're waiting for this to roll out, we need to create a user route that is directly forcing all of the private endpoints to go through the firewall. Now, our data center contains about more than 60 route tables in there. That's that's just because we have a lot of different data classifications, hence different subnets in the VNets. That means that every time a user requests for a SQL database or a storage account or Redis cache or whatever PaaS resource, somebody from network team would have to update all 60 route tables. It's going to be A, time consuming, and B, if they make a mistake, then there's a big loophole on the architecture because suddenly it's an exploit that has direct line of sight to whatever private endpoint was created. So I'm guessing network team would not love that so much. When you think about it, I've been talking about breaking down monoliths, but then I've just discussed an architecture problem. That's because by using modules and workspaces, were able to solve this problem, thank you to Terraform. So we've designed the modules to be like Lego blocks, and you're supposed to build your workspace by adding the Lego blocks that you need to build your infrastructure. As such, in here, we actually use 2 modules, the private endpoint module, which just creates a private endpoint, and the route module, which creates one route to the route table. We've also then used the workspaces for Terraform Enterprise, not the workspaces for Terraform open source. So we have 2 workspaces in here. One is for private endpoint route, and the other one is private endpoint. Now, there's a million ways that you could have solved this problem. I could have created one workspace, which creates one private endpoint, and then propagates all of the routes across all of the VNets. But the problem with that one is it doesn't give us the flexibility. What we've decided to do was to create one workspace to create a private endpoint, and then by sharing its state and using run triggers, every time that private endpoint workspace is, invoked or run, it will then automatically run the other workspaces, which is supposed to propagate all of the routes in different VNets. By doing this approach, whenever Microsoft decides to extend the public preview to Southeast Asia, we can then remove all of the routes that have the private endpoints in the route table. And then we don't need to change any code on the private endpoint workspace because they are divided. So on our case, we wanted to make sure that your workspace would be as small and minute as possible, doing one logic and one logic only. And by using some sort of orchestrator, for us, it was sharing the state and using run triggers, we're able to invoke dependencies that are dependent, I guess, on that workspace. Same as if a subnet is being created on one of the spokes or even on the hub virtual network, it would then invoke, again, the other workspaces to propagate the routes. Rule number 3, write code, but write code with quality. We are putting a lot of importance and dependency on those modules. And so we have to make sure, because there's only one place to define that business logic, we have to make sure that it is of quality. But the big problem is, how do you even test infrastructure? It's not like code that you can just write unit test. So for us, what we did was we used Azure DevOps to automatically do a poor man's way of unit testing, I guess, for infrastructure. So in here, I have a Azure DevOps project called Terraform Modules and a repo specifically for that module. So what we did was one repo equals one module in Terraform. So let's say that I have my main branch and I do another branch based on that on dev and another one for my feature branch. I then do whatever changes is necessary. At some point, I might do a pull request. Whenever you do a pull request, it's going to be for approval of my team. Whoever did the feature branch is supposed to test it locally and make sure, show some, how do I say this? Show some proof of test that the code is working as expected. I guess it's some after commits, everything is ready, it's been approved. You then try to merge it to dev branch. Once it's merged, then the feature branch has lived its purpose and is now being destroyed. We're then, I think, ready to move it, to merge it to production. So we then do a pull request to merge it to the main branch. But by doing that pull request, it will automatically trigger a pipeline. The pipeline would then have these stages: build, deploy, test. And you can see that it would fork at some point for auto and manual destroy. Build stage is very simple. It just does a Terraform plan and Terraform validate. Deploy is Terraform plan and apply. Test is where we do our kind of like infrastructure unit testing. And if all is well, it would go to automatically destroy, because we don't want to be spinning up resources whenever a change in module has been created. When an error occurred on the test stage, it would then trigger the manual destroy, which is supposed to be looked at by my team and see why the module has failed. That test stage is very simple. I know that there are other tools like Terraform, Vagrant, but that required us to learn Go. We stuck to what we know best, which is AZCLI and Bash, and basically from there we did a poor man's way of unit testing. So is the name as I expected to be? Is the region correct? And in here is the address space what I expected it to be. So I guess this is a module for virtual networks. At some point, when the pipeline is successful, it would then allow you to merge to the main branch. And once you merge it to the main branch, you're then good to go. So the way that we use Git tagging as much as possible. Of course, all of our workspace are hard pinned to a specific version for that module so that we don't introduce breaking changes to workspaces that are already working. How we do the tagging is, semantics of it is very simple. Any commit made on dev updates the patch versioning. Any commit made on main updates the minor versioning. And if we had code breaking changes, we would update the major version. So for example, if we decided to change the way that we name certain resource in a module, we would then put it on the major version. Why? Because certain attributes in Terraform would require you to do a destroy if updated, right? So whenever this attribute requires a destroy, such as changing location, changing name, and so on and so forth, then that's going to be a major version update. Last but not the least, prepare for failure, or I guess prepare for learning. This is a space that is constantly moving, constantly shifting, and it's still changing. I mean, Terraform has only been 1.0 this year. So you're not going to get it right, and it's okay, because any failure is a chance for learning anyways. For us, what we tried to do is to try to mitigate mistakes, because this is something that is, we had very little experience with infrastructure as code, and we're then moving all out and doing 100% all of a sudden, right? So it's from 0 to 100 within a few days. So we wanted to make sure that we were doing certain things in a controlled environment. And what do I mean by that? So I'll give you an example of, maybe this is a Terraform workspace with a private endpoint route of, I guess, how we update infrastructure. So, familiar with this is your get branch. And at some point, you're ready to merge the feature branch into your development branch, right? So once you're ready, you then do a PR because you're ready to put it in main. But when you do a PR, you see that it's going to trigger another pipeline. The pipeline looks a little bit different. It's now the build, and then it forks between sandpit and production. And as you can see, sandpit has another stage which allows you to destroy the infrastructure. But I've been saying a lot about sandpit. What is sandpit exactly? Sandpit is our mirror to production. That makes sense. We had philosophical questions on where to put Terraform development. So the initial discussion was, should we put Terraform development in the development subscription, and then it should touch development infrastructure? But then the biggest problem with that is development is production to developers. So we cannot touch that. We needed to have a bubble wherein we can safely introduce changes without any repercussions of touching any workloads. And thus, the sandpit tenant was born. So the sandpit tenant is the exact mirror. It's really the same, the same data center as what we have in production. The only change is that the workloads are slightly different, because we didn't want to be paying multiple VMs for some things that we're not using. But the whole bones of the data center is in there. So at some point when the pipeline is successful, so you do your build, you do sandpit, sometimes you do destroy if this is a workload. If it's a change in the data center, we don't do a destroy because we want to keep it in there. We're now ready to merge it to the production branch. The moment that we merge it to the production branch, it's going to trigger the same pipeline, but this time it's going to fork build to production instead of sandpit. And so that's kind of like how we introduced the change. And this is only for Terraform open source, because if you go Terraform Enterprise, the good guys from HashiCorp already done this for us. The workspace itself allows you to define which branch you want to point into. So for us, if the workspace is for sandpit, we point it for dev. If the workspace is for production, we point it at main. And you might ask me, Krista, okay, this is all good if it's immutable infrastructure. If the infra itself is not changing, this is good because you can test 100%. True. But what if the infrastructure changes? Then this doesn't really help much. Remember when I told you about everything as code? Well, we got super crazy about it. So what I've shown you is a YAML pipeline, so we're using pipelines as code, to actually ingest data in our database. So we're doing pipelines as code, we're using data as code, wherever you can put as code, whatever we can automate, we're trying to do in there. So in here, by ingesting the data in the database for our data warehouse, for example, we're able to replicate the same state as close to production as possible. So whenever your infrastructure can mutate, I think the question that you need to ask, is there any mechanism that I can apply using automation principles that I can keep it as close to production as possible? And for us, it was leveraging all of the scripts available to us and an orchestrator like Azure DevOps. So those are the principles or the tenets that we keep in place and we keep to heart. But reality is, even if you do everything correctly, you always have to account for change, because innovation, it never stops. Remember, we were driven to run this project because we wanted to move fast, we wanted to be secure, and we wanted to be resilient. And that meant talking the talk or walking the walk for our infrastructure as well. The thing is, whatever can change or can mutate will change. So prepare for that. And on our end, 1 year after we've built our Terraform Enterprise, we started looking at it. Is this the most secure, resilient, future-proof architecture that we can have for Terraform? Or is there a better way of doing it? You know, when we started this project, we didn't have feature parity with Terraform Cloud. Terraform Cloud was really starting out, or at least it was very, very new when we started this project. So we did what we think was resilient enough. We had a scale set in there. When the health check failed, the scale set would then provision itself again. So at least we have some HA in there. All of the components are still PaaS. We had geo redundancy and everything in there to be as resilient as possible, right? But nothing beats SaaS. So I'm pretty sure that HashiCorp via Terraform Cloud is going to be a lot better or more resilient or more secure than what we can ever build ourselves. So the simplified architecture or infrastructure was to move into Terraform Cloud and then use the agents to talk to Terraform Cloud and have line of sight on premise and on the private endpoints by using Azure Container Instance. And as such, the managed service identity that used to be the scale set would now be the agents itself as container instances in Azure. We wanted to simplify integration. The way that we provision servers would then reference a workspace, which reference a modules, and the modules uses an image that was created in Packer, and Terraform has to create it in the data center. So at some point, I would have to provision the VM in there, right? But reality is, one of the things that security needs is that whenever you provision a VM, it has to be enrolled on our privileged access manager, which is in Manila. Now, we wanted Terraform to integrate to it directly, but there was no out-of-the-box provider in there. What we had to do was to build we needed to buy another component on our PAM so that we would have integration to Terraform. So initially what we were thinking was that, okay, let's integrate it to Ansible. So Terraform would then pass the initial password to Ansible, and then Ansible would enroll that server to our privileged access manager. Now that's okay and good, but remember, we're always looking at, we had to be 100% sure without a doubt that this is going to work. And if Ansible is down, that means that we've just spinned up a server and maybe not enroll it to our privileged access manager. Terraform does not know the state of how the playbook went in Ansible. Even though we've tested it and even though it's working, we can never be 100% sure. So there's always that 0.001% of doubt that maybe I've never enrolled it. And so we don't want that. We cannot afford that. We wanted to make sure that whenever I spin up anything, it's going to be as secure as possible, and this process could never fail. And so the solution was Terraform should manage that enrollment in there, right? But we didn't have the provider. So one day we started thinking, can we build it our own? And so we started attempting it, and we were able to do so, to our surprise. We built it in a day. And that is a testament to how easy it is by using the documentation and the ecosystem that HashiCorp already gives you. We've decided to use the plugin framework, not SDK v2, because we knew that we wanted to future-proof all of our solutions. And it looks like this is the way forward for plugins as well. But, for us, I've only done 2-3 Go projects. And to be able to do that in one day, it means that it's not hard. It's probably not a skill set, or there's not a lot of documentation out there coming from other people. But if you follow the existing documentation to letter, it's really super simple. And lastly, we wanted to simplify authentication. What do I mean by that? Well, Ansible Tower plays a big critical piece of infrastructure for us. Right now, the way that we talk to servers in Azure, Tower in Azure would have to talk to it. If we need to talk to servers in Manila, which is where our main data center is, we use what we call an isolated node, and then via SSH, it connects to the VM that it needs to manage. Now remember, we have 40 offices in there, and we wanted the workloads to be run locally. So meaning if my server's in Pakistan, I shouldn't be triggering it from Manila or from Singapore. I should be triggering it from Pakistan. So Tower, in this case, only acts as a scheduler. And everything is good architecturally again, but then there's one big thing. The Tower servers and the isolated nodes have to share SSH keys. And basically, these SSH keys have supreme access to all of our Linux servers to be able to do whatever it is Ansible needs to manage. And so there's a scary part wherein, what if one of the isolated nodes in one of the field office is compromised? Then in theory, they have access to all of our servers. So I think security isn't happy with that. So we had discussions with, okay, how can we protect the keys? Do we need to rotate it every day, every month? How complicated is this? And so we started asking ourselves, okay, this is a problem that seems to be generic, or at least a lot of people are facing. How does big tech handle this? And so we started looking at, hey, how does the other companies do this? And we've come across something called signed SSH. Enter Vault. Out of the box, Vault allows us to use signed SSH. So the idea is that Ansible Tower and the isolated nodes, their SSH keys have no privilege to all of the servers. What they need to do is to have it signed by HashiCorp Vault. And of course, the SSH CA has to be trusted by the servers, but it has to be signed by HashiCorp Vault with a time to live setting. For us, it was 5 minutes. And then once it's signed, you can use the signed SSH key to connect to your servers. So it's kind of like having somebody validate your IDs, and only for a limited period of time, I guess. So that's, I guess, everything, all of the use cases that we have to share. Want to go back, like, we wanted to move fast. This project was driven by these 3 things that is required by the organization. We wanted to move fast. And by breaking down modules, by breaking down workspaces, like Lego blocks, we can easily adapt. We can easily be flexible to whatever use case are thrown to us. So one example for us, we had to build our data warehouse in one of our projects. It took us a day to write the modules, to write the workspace. And lo and behold, we had another project that required us to build yet another yet another data warehouse in there. And we were able to provision it in 5 minutes because we write our modules and our workspace as thin as possible so that it's always ready for reuse. Second, keep security in mind, not an afterthought. The way that we enforce our security policies is to place it on the modules per se. But you can never be 100% sure, right? Because maybe the workspace did not use the modules for some reason. It bypassed the modules. Or maybe somebody who's developing the modules actually changed the policies. How can you then ensure it? So we're using the modules to make sure that we should enforce the policies in place. But you can never be too paranoid with security, especially for a bank. For us, what we used was Sentinel. Sentinel then still enforces it, regardless if the module enforces it or not. Sentinel is going to be that bouncer in a club that allows you to go in or out. For us, that gives us 100% confident that anything that's provisioned by Terraform is following our security postures. And last but not the least, design with resilience in mind. By having our whole data center written as infrastructure as code, that's 2,000 or more than 2,000 configuration items that exist as a blueprint in code somewhere, with audit trail, with version history, with all of the commits in there. If we would have done it manually, then it exists on somebody's head. And that's always scary, right? Because A, can you remember every single thing? And B, what if that person leaves? But what is the cherry on top of the icing, on top of the ice cream, on top of the cake, is that if ADB decides tomorrow that we want to build the whole VDC on another region, because we kept it simple. We were one cloud provider, which is Azure, and one region, which is Singapore. But if tomorrow, if we decide like, hey, let's create one in Hong Kong or in Japan, then we're actually ready for it. In a single click, we can actually provision our whole data center in any region because we've designed it with resiliency in mind. We've designed it with flexibility in mind to make sure that we are able to adapt to whatever change is necessary at any point in time. Finally, it's been an interesting year, an interesting journey for us. We know we've barely started or scratched the surface. I'm excited to learn more, to improve what we have, to even look at how we can future-proof all of our architecture. And hopefully you've learned from us too. I guess that's all I have to say. Thank you so much for listening.